Okay, so we just finished talking a little bit about how the equation for a line can actually help us to make real world predictions. And I gave you some of these names of the individual variables that go into the regression equation. So what I want to do right now is talk a little bit about one real world example. We'll talk about another one in class. So let's imagine that you are a student in Psych 391, although this is a little bit different than how I currently teach it. But let's imagine you're a student in this class and you want to know what you're going to get on your final grade, but you haven't gone through the whole semester. In fact, all you've done is to take the first exam. So imagine you've received your score for the first exam and you want to estimate or take a guess as to what your final grade in the class will be. In this case, you know one variable, you know what your exam one score is, but you don't know the second variable, your criterion variable, or the final grade estimate. So your known variable for regression would be along the x-axis, along the bottom, and your estimated final grade is going to be on the y-axis, up the side. So in order to actually make this kind of a prediction, what you'll do is you'll use data. So for you guys, you would use the data from those people who had gone before you. So what I have here is data from the very first time I taught this class. You will notice a couple things. First of all, you'll notice that there are 25 students in the class. That's a lot of people for this class. We've managed to trim down those numbers and make it a little bit more personalized. The second thing you will notice is, as a first-year professor, I was clearly compensating for my feelings of anxiety by massively inflating grades. I'm sorry you weren't part of that original class. Hopefully you're getting more out of this class than they were. They got a slightly higher grade on their first exam, although you guys did quite well. So this is the data that we have. So what you can see here is you can see for any given student, you can see what their exam grade is. And then months later, you can see what they scored for their final grade in the class. Okay, so each one of these is a student score linked in with their score on the first exam and then linked in with their final grade. So you can imagine, and what we'll do in just a second, you can imagine what all this data would look like plotted. In fact, what I want to do is plot for you all those points on an XY axis. So along the bottom here, this is where we have your exam one grade. And up the side, this is where we have the final grade. In other words, knowing your exam one grade, what you want to be able to predict is what your final grade is going to be. So let's take a look and see what that plotted data looks like. So first of all, take a look at the data, and if you were to guess if this is going to be a positive correlation, a negative correlation, or a correlation of 0, what would your guess be? Picture, in other words, where the line of best fit would be. Does it slant up? Does it slant down? Or would it just be a straight line right through the middle? Well, I will show you the line of best fit, or the regression line, that we're going to go ahead and calculate in a few minutes. This is what that regression line looks like. As you can see, it is slightly inclined, slightly in the upward direction. So now, remember, if we didn't have this line, we would just be shooting in the dark to guess what your final grade is. So for instance, let's imagine this circumstance. You know that there is someone from this class. So we'll take our hypothetical billionaire scenario. We have 25 different scores in this class and 25 different final grades. This billionaire draws one of these scores from a hat, but you have no idea which one it is. In other words, you have no idea what they scored on their exam one. It could be way low, it could be very high. You just don't know. And you're asked to guess what is their final grade in the class. Knowing nothing else about them except that they're a member of this class, what would your guess be? Typically, in this kind of a situation, the best guess is usually the mean or the average of the class. So in this scenario, it would be somewhere around this, I think 88.2. If you were just going to make a guess about the score of any random person, you would guess the mean. And what this is going to do is it's going to reduce your error, at least somewhat. much more so than, let's say, you'd guessed way up here. Now you'd be getting these big errors all around. Not just you're getting it close for those guys, but some of these guys you'd be way off. So all things being equal, you always want to guess the mean, or actually what's referred to as the grand mean, the mean of all of these points. But if we happen to know their grade on exam 1, we can use the regression line. So let's take a look and see what this actually looks like. So, for example, it would appear that if an individual were to score a 10 on their first exam, they would receive approximately a 73% in the course. In other words, we're using our regression line to take a piece of data on exam 1 and make a prediction about what they'll get on their final grade. In contrast, if a person were to score a perfect 60 on the first exam, we would predict that they would receive a 94% in the class. But how do we arrive at such a magical line? And what does it mean anyway? Well, ultimately, this line comes from calculations. Calculations. So what I want to do in this video and in the next video is to take you through some of those calculations and to actually show you visually what those calculations look like. So the calculations that go into a regression line have to do with what are called the deviation scores. What a deviation is how much an individual score deviates or differs from the mean score. So in other words, one way of thinking about this is how much above average is a given person and how much below average is a given person. How much above average were they on their test 1? How much above average are they in their final grade? And ultimately, what we're going to take a look at is what are called the co-deviations. And co-deviations are looking at the combination of both those. We did a little bit of this when we talked about correlations. But, for instance, if someone scores above average on exam 1 and above average on exam 2, in other words, if their x1 is higher than the mean of x and their y1 is higher than the mean of y, and 1 just means they're participant number 1 or subject number 1 in our study. So we'll have 25. We'll have x1, x2, all the way up to x25. And the same thing with y1, y2, up to y25. So if x1 is higher than the average of x, in other words, they're above average on their exam 1 score and they're above average on their final grade, what we see here is a co-deviation. In other words, they co-deviate up to that upper right-hand quadrant. So what we'll need to know is a few things before we can actually finally calculate our regression line. We'll need to know each person's scores on x and y. That's nice because we've already seen that, in fact. That's where on our first slide where we looked at all of the data points, we were able to see what is their score on x and score on y, or exam 1 and final grade. We're also going to need to know each score's deviation from its mean. In other words, is each one of those scores above average or below average, and how much? The way that we calculate this is x, or an individual score, minus the mean of x, or minus the class average. And the same thing for y, the final grade minus the average class's final grade. We're also going to want to know what the cross product is. In other words, when you multiply these two deviation scores, what do you get? So in our first instance, remember, we had an x score that was above average times a y score that was above average. So I'm putting a plus here. And when you have a positive times a positive, you get a positive. So part of what we're going to want to know with these cross products is, are things co-deviating in the positive range, or are they co-deviating in the negative range? Next, we're going to want to turn each of those cross products into something more reasonable. Or in other words, we're going to find the average cross product, and that's what's called the covariance. So the covariance, we just add up all of these cross products, and then we divide them by n. In other words, it gives us the average cross product, or what's called the covariance. Next, we want to know what the deviation squared is. So that's going to be easy. All we're going to do for that is we're going to take these deviation scores above and just square them. Then we're going to want to know what the sum of squares is. So in other words, I take all of each one of these deviations squared and I just add them up all together. And then finally, we're going to use all of those scores to get what's called the variance, or the sum of squares divided by n, or the sum of squares y divided by n. Once we have each of these individual components, what we'll then be able to calculate is that beta 1, or the variance, covariance of x, the variance, or covariance divided by the variance of x, my apologies, and the beta 2, beta 0, which is the average of y minus beta 1 times mean of x. Or in other words, remember, this is just like the slope of our line, and this is just like our y-intercept. So all those calculations we did on the page before, we're going to use to actually discover what are the components of our line. So with that said, on our next video, we're going to take a look and actually do these calculations.